In today's lesson from Unit 1.1, we'll be taking a look at notes number 8, which is all about perpendicular lines. The definition of perpendicular lines states that they are two lines that intersect to form right angles. So if we take a look at a diagram, and let's say that we are given some information that line AB was perpendicular to line CD. Now, if we use symbols to represent this, it would look like this. AB with a line symbol over it, perpendicular to CD. So check out that symbol for perpendicular. Sort of looks like an upside down capital T. Okay. So if we're told this, we're given that specific symbol that the lines are perpendicular, then we could use that little box to show that they form a right angle. And we would know from the diagram that angle 1, angle 2, angle 3, and angle 4 are all right angles. So we can put it into writing as angle 1, angle 2, angle 3, and angle 4 are right angles. The definition of perpendicular lines can be used in two different ways. In the first scenario, let's write the definition in if-then form. If two lines are perpendicular, then they form a right angle. So if we check out a diagram, and let's have line L perpendicular to line M. So in other words, and let's label this angle number 1. So in other words, if we're given L perpendicular to M, so that's our hypothesis, then we can come to the conclusion that angle 1 is a right angle, or the measure of angle 1 equals 90 degrees. So we're starting off with the knowledge that the lines are perpendicular, and our takeaway from that is that angle 1 has a measure of 90 degrees, or angle 1 is a right angle. If we take the converse of that statement, meaning we're going to switch the if and the then, switch the hypothesis and conclusion, you can say if two lines form a right angle, then the lines are perpendicular. In other words, if we have that same diagram, and this time around we're given that angle 1 is a right angle, so if angle 1 is a right angle, we could also be told the measure of angle 1 equals 90 degrees, then our conclusion would be to say that line L is perpendicular to line M. So we would use this second case if we're trying to prove that lines are perpendicular, and we'll use this first case if we're trying to prove that an angle has a measure of 90 degrees, or just to say that it's a right angle. But again, both of these come from the definition of perpendicular lines. There are three theorems that we're going to cover that involve perpendicular lines. The first one states, if two lines are perpendicular, then they form congruent adjacent angles. And a diagram of this would be, let's say we have line L perpendicular to line M. So if we're given L perpendicular to M, then our takeaway would be to say that angle 1 is congruent to angle 2. We know they have to be congruent to each other because if the lines are perpendicular, they form 90-degree angles. So angle 1 would be 90, angle 2 would have to be 90 as well, because those two angles form a straight line. Okay, so we can use this theorem to prove that a pair of angles are congruent, but we have to know the lines are perpendicular first. Our second theorem states if two lines form congruent adjacent angles, then the lines are perpendicular. And hopefully this sounds familiar because it's just the converse of the previous theorem. So in this case, we can use the same diagram, but our given information, instead of starting off with the lines being perpendicular, we're going to start by saying if angle 1 is congruent to angle 2. You can see from the picture they're adjacent, they're right next to each other, they have a side in common, and we're given that they're congruent. So if two lines form congruent adjacent angles, then the conclusion we can make from this is to say that line L is perpendicular to line N. So this theorem would be used if we were trying to prove that two lines are perpendicular to each other. Our third theorem states that if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. Okay, so this is kind of a long theorem. So to illustrate it, let's go back to those lines L and N. And let's say that we know from the picture that we have a ray kind of coming through here and dividing this angle into two adjacent angles. So angle 1 and angle 2 are adjacent. We can assume that they're acute. They appear to be less than 90 degrees. And if we know that they form this right angle, then we can say that those two angles are complementary. In other words, the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. So we would have to be told in our hypothesis if line L is perpendicular to M, then angle 1 and angle 2 are complementary. And then another thing you would be allowed to say is that the measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Now for some practice. The directions on our practice problems say, name the definition or state the theorem that justifies the statement about the diagram below. In number 1 it says if angle 6 is a right angle, then line RS is perpendicular to TV. So in other words, if we are given that angle 6 is a right angle, we want to know what allows us to say that those two lines are perpendicular. And that is just the definition of perpendicular lines. Remember, we can use that definition two ways. Either to say if we know the lines are perpendicular, then we can make the conclusion that we have right angles. And in this case, we know that we have a right angle. Our conclusion is that our lines are perpendicular. In the second example, we're told that line RS is perpendicular to line TV, and as a result, it says that angle 5, angle 6, angle 7, and angle 8 are right angles. This is another example of the use of the definition of perpendicular lines. Again, we're told the lines are perpendicular. Our takeaway from that is to say that they intersect to form 4 right angles. In number 3, it says if line RS is perpendicular to line TV, then we get to say that angle 7 is congruent to angle 8. And this is one of our theorems. And it's the one that says if two lines are perpendicular, then they form congruent adjacent angles. So again, if two lines are perpendicular, I'm going to abbreviate some words here, they form congruent. We're going to use ADJ for adjacent angles. Okay, and again, that's one of our theorems from the page before. Okay, it's the first of our three theorems. Number 4 says, if line RS is perpendicular to TV, then the measure of angle 6 is equal to 90 degrees. And that goes back to the definition of perpendicular lines. And number 5, it says, if angle 5 is congruent to angle 6, then we get to conclude that line RS is perpendicular to TV. So check out angle 5 and angle 6 in the picture. And what you should notice is that they're congruent, they're adjacent, and if we have two lines that intersect to form congruent adjacent angles, then the lines are perpendicular. And again, that's a theorem from the previous page. So if two lines form congruent adjacent angles, again I abbreviated adjacent here, then the lines are perpendicular. Okay, so again, check it out. We want to conclude that the lines are perpendicular. The theorem ends with perpendicular. Okay. And finally, in number 6, it says, if the measure of angle 5 is equal to 90 degrees, then line RS is perpendicular to line TV. And that's one final example where we are using the definition of perpendicular lines. Notice that when we are using the definition, it either mentions that an angle is a right angle, that all four angles are right angles, or that an angle has a measure of 90 degrees. Okay?